Ok, đã chụp vào các bạn đứng dậy. Em muốn nhìn thấy tất cả bạn đứng dậy. Các bạn nào còn đang làm việc riêng thì cùng nhau làm xong thì đồng thời. Bạn đến làm xong. Giờ thầy muốn nhìn thấy tất cả các bạn. Nhìn trên nhìn thấy mắt các bạn. Good morning everyone.
Good morning, teachers.
Thank you. Sit down, please. Okay, before I start my lesson, may I introduce the teachers and the lecturers from the university, as well as my supervisors for new curriculum development. Today they are going to observe our class, and we also have our record for the lessons. So may you please give a hand together and welcome them. Thank you. I need to check your attendance first. Top 1, here. Thank you. Lê Đức Anh, here. Thank you. Phùng Quế Anh, yes. Nguyễn Thục Anh, Mai Lê Gia Bách,
Yeah.
thank you. Đàm Trọng Bách, thank you. I still have some noises. Please keep your voice. Right. Phạm Quốc Bảo, Phạm Quốc Bảo, thank you. Nguyễn Bảo Duy,
Yeah.
thanks. Và Nhiên Muộn hả? Chu Việt Hà, thanks. Nguyễn Minh Hạnh, thanks. Nguyễn Bá Quang, thank you. Lê Ngọc Minh, thank you. Nguyễn Phương Thủy, thank you. Nguyễn Đăng Quân, thanks. Khánh Nguyễn Cẩm Thi, thanks a lot. Mai Tiến Thắng, thank you. Trần Công Tiến,
Yeah.
and Nguyễn Minh Tuấn. Okay, may I ask you to help me for record our lesson? Yes, so we have 2 absent today. Okay, before we start our new lesson, I want to check what we have done last time and see how we are going to cope with new problems. I got some questions on the board. Quite familiar with the position and time graph. Actually, I should put there is displacement position instead of displacement. So I just randomly checking your understanding, okay? All you need to understand is what we are already studying and how we use those information to explain the concept of motion that we already know. Okay, the first question, who wants to volunteer to the first one? If not, I will take the name. Okay, could you please? You choose the number for me.
Number 1, please.
Number 1. What is linear motion?
Linear motion. This one is the motion that it's go straight.
In a straight line, right?
Don't have any.
That's good. So linear means straight, right? Thank you. Sit down, please. That's good. You can point to for me the next person.
Okay. Gia Bách, Mai Lê Gia Bách.
Okay, Tabak, could you please choose?
Number 2.
Number 2. Okay, you go one after one, right? Which part of the graph shows the highest speed? Okay, which part? speed, remember. The highest speed.
Six.
How do you know? Show me.
No, I think it's eight.
Why? Yes, but what does it mean about from the graph you can tell whether or not that is the highest speed? Thank you. So actually your questions, your answer is correct. Can please to explain more a little bit?
Only in 2 seconds, the speed is 4 meters per second, but in P, the speed is 2 meters per second.
Okay, thank you. Actually, we already understand that by looking at the slope of the line or the gradients of the line. The steeper the line indicate that higher speed, right? And if the line is going to the positive direction, it means the velocity is positive, is the class or the objects is moved in positive directions. In this case, we compare between part A, part C, and part D. We see part A have the steepest, so it's got highest speed. Okay, that's good. Back, could you please assign me for another question? Okay. Yes. You choose. Number 4. Good job. What is displacement? That is vice versa. You should compare with the final to the initial rather than initial to the final, because we already looking at the process from the beginning and to end. Thank you. So we compare the position of the final position and the initial position. We find out the displacement. Okay. Okay. What is velocity? Could you please help me? Two time or per time divided by okay, thank you. So she said that velocity is the displacement divided by time. Actually, the concept is when the position changes with respect to time. So we take the change of the position divided by the time taken. We have the velocity because we have the directions and the magnitude divided by time. Then we have the velocity. So some of the concept you already know. Change in positions mean motion. Change in position with time, which is the velocity. Something is still missing in the picture, so we are going to study it today. Okay, we'll move to the next part. So this ones you already know. I just try to recap. So the positions is something you need to compare with the original point, or that is called reference point. And the displacement is change in position. And if change in position is called velocity. However, the motions is already with a constant velocity?
No.
What do you think? Okay, we're already familiar with the constant uniform motion, right? Okay. And today, what we are going to study is the aim is we talk about what is linear uniform accelerated motion. And then we are going to discover a new term that help us to describe the motion much clearer. So by looking at this one, we are going to define what is the linear uniform accelerated motion and discover new terms. Okay? And I just put the question mark here. Some of you already guessed what the term is, but let's see how we define them. Okay. Before this one, I want you to looking at my demonstration. I got a table here. You're quite familiar with the motions, with linear motion, right? You got a count?
Yeah.
Wow, it's so speedy, right? Okay, observe my demonstrations and try to figure out the differences between 3 times when I do the demo. Could be a little bit too low for you. So is that the guy at the back? Can you see that? Can you see that now?
Okay.
Okay. Okay. Just observe whether. Forgive me about the first part. Okay. Look at the middle part and compare. First, the part of the motion. The second, how is the speed? Are they the same, similar, or changing? They're a little bit. Sorry. What do you think?
Constant.
Quite right. So quite familiar with what we already know. But could you please hold that side, please? Catch this car. Can you guess what will happen if I release the car from the top of the hill?
Just accelerate or increase.
Oh, you already got some words in the head, right?
Accelerate.
Now hold it. Look. How are they moving?
Faster.
Oh, they're getting faster and faster. The part is still straight or is curved?
Go straight.
It's curved? Okay. Okay, can you just put this up and you see that the car move uphill? What happened with the car? What happened with the car when it's go uphill? I did. Okay. Thanks a lot. May I have it? Okay, will you please open your book on the notebook, and we are going to discover more about today's topic is linear uniform accelerated motion. Okay, could you please tell me, if I do that demos, you can feel that the car speed changes. But in fact, how can we make sure that something is changing its speed? How can you determine that? Can you think of the way or the methods that can help you to actually tell the person next to you that I can prove that by the evidence? How can you do that? What kind of methods or what the solution you can think of?
I'm thinking how to demonstrate things.
Okay, but you can demonstrate you can talk in Vietnamese. Oh, we can look at the slope, right? So actually we need to find out before, when we talk about linear uniform motion, we measuring the different distance or displacement after the interval time similar, right? So we are going to do that as well today. So if I can somehow mark the position of the car every second or every half a second. So each position here will show you, right? And if you can calculate that one and you know the time, then you can draw the position and time. And from there you can talk about what is the pattern of the position and time. So in order to do that, because I don't have the equipment with me, I already got the ticker time printed here and give it to you. So you will, each of you will have one strip, exactly look like that, and it's already tell you where the starting point and where the ending point. Your task is using this dot and start to help me, no, for you, not help me. However, using that one to make a graph of positions versus time. And each dot represent of the position of the car every 0.5 seconds. So could you please hold one and pass the rest on for me, please? Okay. Hold one and pass the rest on. Each one will have one paper. Okay? and I'll give you the, no. Each one of you will have one. So you have this, you have this, you can divide, okay? Here you are. Use a ruler to mark the position. Thank you. Yes. You need help? Raise your hand. Yes? Okay. You have 5 minutes to complete this task. Intervals is mean one after one. So each dot will have the time move from point 1 to point 2 is half a second. 2 to 3 half a second. So we have to measure this position. So as we have to draw the time and the position. From here, you can draw its position in the centimeter and second. So you can divide this part h with 1, 0.5, 1.5, 2, 2.5. Now, maximum you can make is about 8 dots, okay? If you found difficult, work with your pair. You choose one and work. That's good. Yeah, another trick to help you quickly to calculate is the graded papers. Here already got divided very accurate with centimeter. So you can use that one as a ruler too. So don't have to worry whether you have a ruler or not. You can draw this one. Each one has is 0.5. So you put here this 0.5 second like that. So you start to mark this one up to here. So you mark it up. Okay, from here 0. So you go up if you choose this one. This one is 1 centimeter. So where's 0.2? Okay. So you come here. Okay. That's right. So you have to do the. Quickly draw that. You have 3 more minutes. Please, I give you some more. So try to, as much as you can, if you can't do it accurately and you know how to do that, try to figure it out the shape of the line. Exactly. So just measuring this one. Okay. From here to here is 0.3, but it's up to here is only the distance from here. So the position of the first point is 4.3. This one is 8.2, right? And 8.2 plus with 3.4 is how much? 11.6. Okay, so from there you start to draw some of it. How many of you already got the ideas of the shape this look like? Probably that's good. Some of you already finished. I think if you can't do that, we keep these ones for go home and you try to figure it out. Okay? I think easier for you and much familiar when you draw a straight line. Some of you already done that. Okay, could you please stop for now and we continue to do that at home. You keep that one and turn it back to me later. Okay? Okay, drop the pen and look at the board, please. Are you ready?
Yeah.
Still see some of you still working? Okay, drop the pen and look at the board. So it's quite easy and fast if we do something is familiar when we work with the linear motion, right? But when something changes, you start to got some trouble. It's easy to understand, but I believe that give you more time, you can finish it. However, this is the shape it should look like. Now, can you figure it out what the white line represent for the motion? What type of motion is that? Okay, could you please tell me? The white line represent for what? What type of motion? Linear, uniform motion, right? So that shape is quite familiar. What do you think is the yellow line? Fuan? The yellow line. What do you think? What type of motion is that? Is it speed up or slowing down? How do you know? The line is curved and that is curved. No changing in position, right? And the last one? The last one, the blue one. If increasing, that's right. So we got different lines. So the patterns here, quite straightforward. When we're looking on the position and time, and if the graph is straight line, it indicates that the speed or the velocity doesn't change at all. However, the demonstration showing that the velocity may change. And the curve we have will indicate that. So if you can show the person that if the curve is going up, it means take less time, travel a longer distance. It means it speed up. And then if the curve is like this one, is called concave, right? The concave go down, or convex, it means slowing down. Okay. So, what does it mean? We see that even in a straight line, but the velocity is changing. And that they define as the linear accelerated motion. Okay? So the definition of the, you may write this one down. The linear accelerated motions is a moving in a straight line. But here we got some kind of special, is with a changing uniformly. So the linear uniform accelerated motion is the motion in which the change in velocity in each unit of time is constant. So by the definitions, it's very straightforward. Linear, it means still in a straight line. Uniform, something changed, but it's changed uniformly. So the same like before, we have the distance, have the same distance in each time interval. So this time, it changed velocity in each time interval. Something I asked you before. We define that change in positions with time is velocity. So what is the name? What is the physical quantity? Describe the change in velocity with time. Can you guess it? Do you have that concept? Yes. So we still, how can I describe that? If I should use the word only, or we have special word describing the change in velocity with time. Anyone got the ideas? I heard that from beginning of the class. Some of you already said. Accelerate is the verb. Accelerated is the verb. So acceleration. Thank you. So we have a new concept today. We have the acceleration. So what is acceleration? Is what you just said. Acceleration is the rate change of velocity with time. So the second concept we want to talk is the acceleration. And this is the main concept for today. The main concept for today. Acceleration is the change in velocity with time. So can you tell me the change in displacement or the change in position with time? How can it become velocity, right? So how can we write down velocity? It changes in position. How can we write it down? Equal to final point minus 2 position of initial point divided by time. So if the same similar expression, rate change of velocity with time. So can you write up rate change of velocity? So which part changing now? What change? The position or the velocity? Velocity. So what should be in the above here? V final. That's good. Continue. Who that?
Minus V.
Okay, come here. That's good. Initial divided by time. That's good. So this called the acceleration. And similar. Similar. I'm not yet give you a little bit here because we already got. Okay, last time I teach you and you know that velocity have the instantaneous value as well as the average value, right? So the same with acceleration. So come on, velocity is a vector or scalar? It's a vector. How is a vector quantity can be changed? What can we make the velocity of the vector quantity change? How many ways of doing that? Yes. Yes? Yes? So what else? What is that? Can you name it? For vector, we have 2 ways. What is that? We change what? Direction. That's good. What else? What? Big. That is called magnitude. That's good. Thank you. Well, you need to think a little bit more. Yes.
I have a question.
Yes, please.
So by using that equation, I want to V final minus V initial.
Initial.
So it just conclude that we also have the constant like speed at the moment.
Well, if what happened with the constant velocity, the V final and V initial will be if the constant velocity. So V final and V initial, is that different?
Can I ask you again, Miss? Can I ask you again, Miss?
Yes.
Ý con là ở đây ạ, thì con nếu mà con hiểu thì cái công thức kia ấy, thì có nghĩa là nó chỉ đang tìm một cái, có thể nó vẫn đang tìm một cái số cái vận tốc nhất định ạ, ở trong cùng quãng thời gian ấy. Nhưng mà ở đây thì tại sao nó không phải là ví dụ nó là cái tốc độ khi mà nhanh quá thì nó sẽ chỉ là lấy cái x của một phần trừ đi cái cái x của một phần trừ đi cái x của một phần còn lại chia t.
Chia cho t thì ra con ra cái gì nhỉ?
Thì nó sẽ là cái nó ra cái tốc độ của
Tốc độ trung bình trong khoảng thời gian đấy.
Thì khi mà mình so sánh những cái khoảng tốc độ đấy thì mình sẽ thấy cái nào cao hơn thì nó sẽ là acceleration.
Exactly.
Tại sao không làm?
Cảm ơn con. Chúng ta có làm thế, và bởi vì là ở đây nếu chúng ta mà làm, chúng ta sẽ đo bài tới khi thực hành các bạn, chính là cái ý kiến mà chúng ta sẽ để dành trong tuần thực hành. Làm thế nào để đo được như vậy? Bạn đưa ra một ý tưởng rất hay. Chúng ta sẽ tính được cái vận tốc trung bình trong cái khoảng thời gian liên tiếp. Sau đó chúng ta xem là nó thay đổi cái tốc độ trung bình đó như thế nào. Đấy chính là cái ý tưởng của bài thực hành. Còn đây chúng ta đang đưa ra từ khái niệm định nghĩa, và vì các bạn biết được khái niệm định nghĩa này đã là thay đổi vận tốc theo thời gian thì sẽ gây ra gia tốc. Vậy thì chúng ta đang biết là vận tốc thì có là hướng và độ lớn, hay là gì ạ? Phương, đúng không? Phương chiều, độ lớn. Thì bây giờ cứ bất kỳ cái gì trên đều thay đổi đều có thể gây ra gia tốc. Và cảm ơn bạn, chúng ta sẽ quay cái trở lại đấy, sẽ dùng nó làm cái cơ sở lý thuyết cho cái bài thực hành sắp tới khi đo gia tốc. Okay? Okay. So if it can be changed, so could you please look at this one? The car stand and then it's go with a very high speed. So it's speeding up. So this is change in speed, right? Change in magnitude. What about the next one? What is changing? Simpson is brake because of the red line. So he's moving with a certain velocity, and then he stops. What changed in his driving? Yes, what changed? So is that change in direction or change in magnitude? Change in magnitude, that's right. So from some value to 0. And we already know that drag racing always like dripping, right? Totally turning. So anytime when you see changing directions, that is also indicate that there is an acceleration. Okay. Okay? Okay, this is the note that you need to talk. And exactly, when you talk that about when the velocity doesn't change, then the final and the initial will be the same. And therefore, this value will get to the 0 value. And at that time, we say that no acceleration when uniform motion. Okay? Linear. Uniform motion. So we need to understand that any change in magnitude or in direction will lead to that change. Okay. And thank you for that one. This is the way we are going to calculate that. You already taught this one in the previous questions. So this one is expressed in a word that the average acceleration is change in velocity divided by time interval. So can you tell me what is unit of acceleration from there? In SI unit, what is SI unit of velocity? Meter per second. Now change in velocity by time. So you divide by time one more time. So what is the value? What is unit? Meter per second square. That's good. So exactly, the SI unit of accelerations is the meter per second square. Or sometimes they write out in short form is meter time square minus to the power minus 2 is also another way of expressing that. So if now I give you the example of initial velocity and final velocity, can you calculate the acceleration? Can you do that? Try it, okay? Example. Example. First, tell me, what is the directions of motion? See? Tell me, what is the direction of motion? From left to right or right to left? Left to right, so it's a right word. Right? It's moving rightward. So the velocity, what is the initial velocity? What is initial velocity? 0. What is final velocity? Okay, 16. So V initials is 0 and V finals is 16 meter per second. So the car is moving in, if we choose the position, the x direction is a positive direction. So what is the value of Vf and Vi? Is that correct or not? So because it's moved in the same position, positive direction, so the value is positive, right? So can you just substitute in and tell me what is the value of acceleration? How much? 4 for what? That's good. So we already have to remember the unit of any physical quantity. If you forgot that, you got trouble, right? So we need to calculate the acceleration. So we know its address, it means 0. And 16 meter per second is final. And the time 4 seconds. So easy, right? Just substitute this in and you see that value is 4 meter per second square. Is that easy or difficult? Easy. Okay. I think it's the time for you to test some understanding.
Why?
Yes?
Why if I take all the velocity divided for all the time, I will have a different answer.
You take what?
All the velocity and all the divided by all the time. Like I take 2 plus 6 plus 11 plus 16.
That's a good question. It will become out with differently. But what is the definition of acceleration?
It's a
Change in?
velocity.
Change in velocity. So when we talk about the change in velocity, what should we care? We care about in the middle, or we care only in the initial point and final point? So we don't care much about what's happening in the middle. We only see what change compared with the initial condition. So the initial point is very important, and final point is very important, and also the time interval. That is 3 components define what is the acceleration of the objects. Okay, one more question. Okay. Could you please tell me what is the direction of motion? If I still choose x direction is positive, left to right still rightward. So what is the initial velocity? 8 meters per second. What is final? What type of motion is that? Is it speed up or slowing down? So what is acceleration? Average acceleration. V initial or final? Final. Minus initial divided by time taken. Is 0 minus 2, 8 divided by 4 is minus 2 meter per second square. Okay, that's good. Could you please open the computer? We have something to. Yes, please. Được. Ok, các bạn nào không có máy tính không vào được, các bạn dùng điện thoại. Thầy mở cái này cho nó có tí wifi vào cái phòng này. Ok.
It has a Wi-Fi.
No Wi-Fi.
No Wi-Fi. Technology.
Don't you want to work with pair. So the top two will have. So top two, okay? So two last student will have H2 stem.
3.
Top two. No, top 3 I don't have. That's okay. Top 2. So you have top 2 2 star. And 1 star for the second one. First prize and second prize. Okay. Hopefully it's work.
We haven't had a call.
You got what?
Call.
The code, yes, is coming. You want to hear the music? Yeah. Make you less. Hopefully it's work. Otherwise, I don't know what I should do.
You should connect to Sabrina Viet.
You should escape from the slideshow. Escape from the slideshow first.
Okay, here you are.
Hai người máy ạ?
Team 1. Hai bạn một máy. Hai máy cũng được mà. Bạn nào máy nào mà còn sống thì còn chơi được. Không nó đốt mạng nửa chừng đấy là thôi hả? Chọn team bất kỳ đi, cho thật nhanh vào. Cùng một tên được. Today you got good question today. So that's very good because thinking in that way is actually what we are doing. Every time when we do experiments, we think of the way we solve the problems, analyze the data. Okay, you're going. That's good. Be quick, be quick. What is that? Hold the member. Hold the member. Okay. Ready? Được luôn, bách được luôn. Okay.
Never mind.
Okay, start. 3, 2, 1, go.
Oh, well, this is questions.
What happened? Really?
Oh, okay. Well,
Huh?
wow!
Wow! The average acceleration can be calculated by using which formula? V initial minus V final. Be quick, be quick!
Thầy ơi, thầy sai sao nào? Sai vé.
Typing. Sorry. Correct that?
Pretty much. It's okay. Nothing needs to be.
So unit of acceleration. We have enough time. Just okay. So it's actually meter per second. A cheetah takes 3 seconds. seconds to accelerate from 0 to about 3 meters. Quick, use a calculator. You've got 1 minute. 1 minute to calculate. 3 seconds. No, not sharing. Please focus on calculating. Calculator. D. Is
11.
We should skip.
no, we don't
We
skip
have
it.
a tough answer.
No, if we skip now, it's stop. So if you walk quite fast. That's good?
Oh, what?
What? Yeah. Right. What happens? What's that is the tricky, right? So you need here. I only transfer it from 120 kilometers per hour to 33 meters per second. Divided by 3. So be careful. Focus. An object has no acceleration. It is moving with constant speed. Why? Tell me why. Yes. Same speed, but what changes? Direction. And we know that velocity have 2 components. Direction and magnitude. Okay, be careful. The last one. Another one. The second last one. Downward moving elevator. Slowing down. You stand on the elevator. It's going down, but it's slowing down. What is the direction? Yes. Actually, it's a tricky question. You have to think carefully. Upward. Why? Can you explain why? We're going down, so the position now is pointing down, but it's slowing down. So V final smaller than V initial. So it's opposite. That's why acceleration is up. Last one. A skydiver. Velocity is 0. What is the velocity of the skydiver after 5 seconds? If the acceleration is 10 meters per second square, we still have 5 minutes. Who will be the winner? Be quick. Be quick. So good. Actually, in general, in fact, the skydivers talk about 30 seconds in free fall, and then from there something starts changing because of the air resistance. We are going to analyze that later, okay?
Yeah.
So we see.
Yeah.
Khoa, anh Tiến. I will stand for you. Okay, take note for me, please. Okay, my last question. What are 3 controls on car tension, its velocity?
time
Which one stand for that person?
time running
The control of the car. What control the car? Can change the velocity of the car. Who want? Yes, please. Time. Direction. No. On the car.
steam paddles
Yes, be quick.
paddles
No. Okay, go here. What pedal?
speed paddle
Accelerate. Acceleration pedal. What else? And steering wheel. That's right. So 3 components. That is brake pedal, accelerator pedal, and steering wheel. Okay. And today we are studying about. Okay, may I sum up? And then you go. We study about linear, uniform accelerated motion. We talk about acceleration. Newton describe the change in velocity. And we know the value of average accelerations over time. And if that is constant, acceleration is constant, it means the change in velocity is uniform. That's because of uniform accelerated motion. And this one, next time we are going to continue, okay? You can skip this part, only remember from the last part. Homework is here for you. I got the homework here. Distribute for each of you. And I hope that you are going to have sometimes that triggers ahead. Next time we have acceleration to describe. If you finish, remember to read this part before going to class next time, okay? Okay. Any questions before we go? No. Do you understand what is acceleration now?
Yes.
Okay. And remember, for those who hasn't finished the graph, do it at home. And submit it next time too. Okay? Today we still have that activity not yet done. Okay, thank you very much for your